Okay, so we're now recording this session. Welcome to Python 101. I guess we'll have people coming in over the next few minutes, but I'd like to just get started. This is our Moodle for KIMEP Data Science Lab. We've got a Data Science Lab Telegram group, which is different from the Python 101 tutorial Telegram group. So this is our main group, Data Science Lab. We have a GitHub repository. My name is Jacob Reedhead. This is my email, and you're here on my Zoom. On this Moodle, we have, I haven't used the announcements yet because I'm putting most of the announcements in Telegram group, but I have a link here for software installation and troubleshooting. If you haven't, so we had a prep session last Friday. We had about 30 people come in, and this page has some links to installing Python, also Jupyter Notebook. There are 3 ways to install Jupyter Notebook: Anaconda, Jupyter Lab, or Jupyter Notebook. I'm not going to cover those today, but if you haven't installed Python and Jupyter Notebook yet, I encourage you to do that, because the tutorial it's about Python, but it's in Jupyter Notebook. And so if you have Jupyter Notebook, then you can access these materials and follow along during the tutorial, or you can practice the code later. So you have 3 options for installing Jupyter Notebook. There's a note here about installation and some troubleshooting. And lastly, these materials are also available on Github Desktop, because not everybody has access to the Moodle. So to use
Professor,
that,
we can't see your screen, Professor. Sorry.
Oh, sorry. I'm sorry. Okay, sorry about that. Yeah. So back here. So this is the Moodle, the KIMEP Data Science Lab Moodle, and some basic information about the group. Here's the software installation and troubleshooting page that I was talking about. Okay, so yeah, Python, Jupyter Notebook, and then GitHub Desktop. You don't have to install this if you have the Moodle, because I will upload the Jupyter Notebook folders to Moodle as well, but also I'm uploading them to GitHub, and they're open, so anybody can access them. The video recordings for these tutorials I will upload to Moodle. I'll have to see where I can upload those, because Moodle has a file limit and a size limit, and they probably won't be able to fit on Moodle, but maybe I'll put them up on YouTube and then just put links here. So I'm encouraging you to use GitHub Desktop, because it's such a common tool for data science. So we can practice using it during the tutorial to access the Jupyter Notebook files. So those are here. If you have trouble installing any of these software, like, message me later one-on-one, not in the whole group, and I can try to help you get that sorted out. Lastly, we have the Python 101, the tutorial resources here, including the link to the GitHub repository, the Telegram group, and I will be uploading everything here, the links to the videos, and also the Jupyter Notebook code that we're using. So this is the Moodle. If I haven't added you to the Moodle yet, if you registered with a KIMEP email address, I should have added you to the Moodle so far, unless you registered like in the last day or so. But if you registered with a non-KIMEP email address, then please send me your KIMEP email address in Telegram, and I'll add you. So, any questions really quickly about the Moodle? Okay.
No.
Okay, great. So let me show you the GitHub Desktop really quickly. So this is GitHub Desktop. GitHub Desktop allows you to access repositories on GitHub. We're using the KIMEP Data Science repository. So if you choose this repository and then you go over here and fetch origin, it will allow you to update your repository. I just uploaded some new files there. So if you want to follow along with today's tutorial, you should do this. So you can add the repository by cloning repository. Go to the URL. If you haven't done this already, the name of the repository is KIMEP Data Science Python 101, like this. So Soljake/KIMEP Data Science Python 101 and clone. And that will add the repository to your list of repositories. And once you've done that, you can go over here, fetch origin, and this will pull all the files, the most recent files. And then you can see these in two different ways. You can click here to view it on GitHub, which will take you to the web-based format. And you can see I've uploaded day 1, 2, 3, 4, 5. Day 2, 3, 4, and 5 I have not finished. They're up there, but they're pretty much empty. Day 1 has today's content. But rather than opening it up here on GitHub, if you go back to GitHub Desktop, you can click here on Show in Explorer. And whether you have a Mac or a PC, this should work. And this will show you the same files in your GitHub, in your local GitHub folder, wherever you save that. So here you have all of your repositories in your GitHub folder. And then here in the KIMEP Data Science Python 101 repository, we have the same 5 folders. And the Python 101 day 1 data types, this is the folder we'll be using today. So again, and you can see the extension for this file is EPYNB. This is the extension name for Jupyter Notebooks files. So we'll be using this one today, but I'm not going to double click on this. Instead, to access this, I'm going to access through Jupyter Notebooks in a different way. So let me show you that. Okay, so here I have Jupyter Notebooks open, but I'm going to actually close this and reopen it to show you how. So if you've installed Jupyter Notebooks, if you installed it through, if you installed it through Anaconda or through Jupyter Lab, then those programs have user interfaces. So you can just open those programs, right? So here's Anaconda and Jupyter Lab. If you installed one of these 2 programs, you can open your Jupyter Notebook this way. If you installed just Jupyter Notebook and not these Anaconda or Jupyter Lab, then you have to access Jupyter Notebook through the command line. So I'm going to do that. I'm going to my command prompt, which in Mac is like terminal. And then I'm just going to type in Jupyter Notebook. And that will open my Jupyter Notebook program here. And it's going to show you your system directory. And then remember, the file that we want to access is Python 101 day 1. So to access this in the GitHub folder, I have to navigate to my GitHub folder. Yours is going to be somewhere else. Here's the KIMEP Data Science Python 101. And today's tutorial, Python 101 day 1 data types. I open that up. And this is today's tutorial content. Okay, I'm going to pause for just a second before I jump into the tutorial and go any further. Any questions about how either Moodle or GitHub Desktop or Jupyter Notebook.
Yeah, could you please show where should we download it from GitHub again, please?
The Jupyter Note, this file.
Yeah, this file.
Yeah. So in GitHub Desktop, if you have cloned the repository for KIMEP Data Science Python 101, then you can fetch origin. And what this does is it pulls the files from the GitHub website onto your local version of this repository, which is here in your GitHub folder, right? So, and then you can access this folder by clicking here, Show and Explore. So if you click here, it should show you the file that you've just fetched from GitHub. And then, like, as I said, the way that I'm going to access this tutorial is through the Jupyter Notebook program. So here's the. Any other questions about, I want to ask, let's see, we have 76 people in the room right now. How many of you have this Jupyter Notebook file open right now on your computer and are following along, can follow along in Jupyter Notebook? Okay, so we have about 76 participants right now, and we have about 21 people who have raised their hands. So about a third of you have gone through this process. You have Python installed, you have Jupyter Notebooks installed, you've downloaded the tutorial, you've opened it in Jupyter Notebook. For the 2/3 of you who haven't done that, I'm hoping that by tomorrow you can get to this point, right, where you've installed Python, you've installed Jupyter Notebook, you've installed GitHub Desktop, you've cloned the repository, pulled the file, and you're able to open this up in Jupyter Notebook and follow along, because it'll be much more instructive for you if you're able to follow the tutorial line by line as we go through it here. So okay. So without further ado, let's get into it. So welcome to the Python 101 tutorial. This is data types and control structures. So this is day one. A little information about the course. It'll be offered Monday through Friday this week, 9 a.m. to 10:30 a.m. Almaty time. Here are some links. You've all registered in the Google form. Here's the Telegram group where we're giving updates. Here's the Zoom link, which you're obviously using right now. And these materials in GitHub and Moodle. I'll put the Moodle link up here too. I mentioned Moodle. For those of you who are attend all 5 sessions and pass the basic skills test at the end of the week, we will provide you a professional certificate from KIMEP. If you're only able to attend some of the sessions, like you can only attend some of the days, that's fine. You can join whenever you're free. Just to clarify, though, the certificate will only be offered to those who are able to attend all 5 sessions and take the skills test at the end. We are planning a tutorial series. So Python 101 is the first in a series of tutorials that we plan to develop over the few months. Here's a tentative list. So the 100 series are coding basics. So Python 101 and 102 will cover data types and control structures, functions and algorithms in Python. We'll have some parallel, I plan to do a parallel series, R101 and 102 for the same topics, but in the R language. This 200 series goes beyond coding basics to focus on topics useful for data science, including data wrangling and visualization. So there are two different, Python and R both have libraries that are really useful for data wrangling and visualization. In Python, that's pandas and plotly, and there are many others. And in R, Dippler and ggplot2. So this 200 series are really planned for data wrangling and visualization in Python and R. And lastly, more advanced topics will be the 300 series, such as natural language processing or machine learning algorithms. In R, linear and logistic regression models, exploratory analysis with, say, factor and cluster analysis, and other kinds of advanced topics. So this is kind of how we're thinking about 100 series, 200 series, 300 series. So more, if you like this tutorial, hopefully we'll have enough interest and we can continue on to these other tutorials. For this Python 101 tutorial, today we're going to talk about primitive data types. So numeric data types, integer and float, the Boolean type and the string type. Tomorrow, we're going to cover non-primitive data types, which include such as list and dictionary. Wednesday and Thursday, we'll cover control structures, such as if selection statements and repetition statements, such as for loops and while loops. So I'll introduce those basic control structures on Wednesday, and then Thursday, we'll kind of look at more complicated combinations of those. And then Friday, we'll look at some practical issues of running Python on your system. 3 ways to run Python, input and output with files, and also operating systems and directories using the OS library. So, so this is kind of the outline for this week. Okay, any questions about this before I jump into the actual coding? I promise tomorrow we'll bypass all of this and go straight to the content, but I just wanted to kind of get these basics out of the way. Any questions about the course info, registration, certificates, etc.?
Professor, may I ask the question?
Sure.
How the attendance will be recorded?
I'm just recording attendance from my Zoom gives me an automatic list of everybody who's attending. So I'm just going to do the attendance off of the Zoom.
Okay, thanks.
Yeah. Okay. All right. Any other questions? All right, let's jump into it. So I've included for each of these topics some relevant links to tutorials. So first, since today and tomorrow we're talking about data types, let me show you a very quick, here's a helpful link in W3 Schools to Python data types. There are some built-in data types. These are what we're going to talk about. We'll talk about these today and tomorrow. You have a types for text, which is str, which means string. You have numeric types like int and float. This is like integer. Float means like it's a data type for decimals. Sequence types include like list, tuple, and range. We'll focus mostly on list. Mapping type like dictionary. There's some set types. Set is very useful, but we won't cover that probably until a more advanced one. And then Boolean types like true and false Boolean. And then some binary types and none type. None type we'll probably cover in a later tutorial as well. So, so this is basic data types. Here's a link to this. So let's start with numeric data types, integer and float. So you can use Python just like a calculator. 2 plus 2, you run this is 4. Let me actually restart this. Let's see. I don't want you to see all the answers already. Don't have all of them. Okay, so go ahead and this is going to be an interactive tutorial. So 2 plus 2, right? Run this, it's 4. Now, a very helpful function in Python is this type variable. It tells you what the type of the variable is. So what's this going to give me? What's the type of 2 plus 2? I mean, we know 2 plus 2 is 4, but what is the type?
Integer.
Right. So it's integer. It's an integer. If you use the subtraction or multiplication, so order of operations holds here, right? So 50 minus 5 times 6. What's this going to give me?
20.
20, right. But even though minus is first, we do multiplication first. So Python recognizes basic order of operations. What will the type of this expression be?
Integer.
Integer, right. You can disrupt the order of operations using parentheses. So 50 minus 5 is 45 times 6 gives us 270. Okay, now something interesting here. 50 minus 5 times 6, we know that's 20 divided by 2 will be what?
10.
10.
It'll be 10, but look at the answer, it's 10.0. So why did we get a 10.0? So if you look at the type of this expression, it's a float now. Even though 10 is an integer, division always returns a float because there's the possibility of having a decimal, right? So integer is, the integer type is only when you do operations on integers, you will get an integer, except when you are dividing, you will automatically get a float, which is a decimal type, right? So, and then what's the value of this expression?
$35.05.
Yeah, so order of operations, we do 5 times 6 is 30 divided by 2 is 15. 50 minus 15 is 35. But because we introduced the division operator, we're going to get 35.0 instead of 35. Now, I can recast this as an integer, and that gives me 35 as the integer, right? And you can see here, this has a 0.0 and this doesn't, right? So you can recast a float variable as an integer like this. The number is the same and it will be treated the same as, you know, whether it's 35.0 or 35. But just know that the data types are different here. This is a float and this is an integer, right? There's some special operators. The double slash does floor division, which removes the fraction. So 17 divided by 3 is 5 point something, right? Let's see here. Right, 17.3 is 5 2/3, but 17 with two slashes gives you 5. And so this is it's very helpful. It's a floor division. It removes the fraction and it just returns an integer. So the data type of this is going to be float. The data type of this will be integer. So let's see. Okay, so oh yeah, I have the type here. Okay, the modulo operator returns the remainder of the division. So 17 divided by 3 is 5 remainder 2. So this modulo will give you 2. And the squared operator, these 2 stars, will give you squared. So 2 squared, 2 to the power, right? So 2 to the, sorry, it's the exponent operator. So 2 to the 3rd power is 8, right? 4, what's this going to be? 4 to the 2nd power will be what?
16.
16, right? What about this?
Two.
Would be square root.
2. Yeah. So it's right, square root. So okay, so that's the exponent operator. Okay, now let's talk about the equal sign. The equal sign assigns a value to a variable. So when I run this, what's going to happen?
Nothing.
Yeah, the output will be nothing. There's no output, but the number 20, the value 20 has been assigned to the variable width, right? And then height. So don't expect some output when you assign a variable to a value, but it has been done, right? So now if I run this, what will I get? What is width
100.
times height?
100.
Right.
100.
And what if I run this? What will the output be?
4.
Okay, trick question. So the ratio will be, the value 4 will be assigned to the variable ratio, but there won't be any output. And now if I run ratio, there will be 4. And it'll be 4.0 because remember division makes these integers into a float. So let's look at the type. What's the type of width?
Integer.
And height
Also integer.
and ratio?
4.
Right. Okay, what happens if we run n? Or let's just call this, we have height, width, and what about length?
Error.
We did not define it yet, so
Right,
nothing.
exactly. So it's a name error and the name length is not defined, right? So, so that's pretty common. Okay, and then we also have comparative operators like greater than or less than. So width is 20, height is 5. So if I run, so is width greater than height is true or false?
It's true.
True. So these comparative operators are going to return a Boolean value, which is true. Width less than height is false. If I set these equal to each other, width equals 8, height equals 8, then width greater than height should be false. And then these should be true. Right? If 8 is greater than or equal to 8, 8 is greater than or equal to 8. Okay, so these are some comparative operators that you can do with integers and floats. So that's everything that I want to tell you about numeric types. So let's move on to the Boolean type. So there's a tutorial here. Oops, sorry. Oops, sorry. So you can follow this tutorial. It also has some great things about Boolean operators, Boolean comparison operators, testing. So true and false are Boolean types. So if you run the type on true, it's bool, and the type of false is bool. So these are used for, we saw these are used for comparisons. We also have Boolean comparison operators such as equals equals and exclamation point equals, which means not equals. So here, true equals true. This actually runs an error, right? Why is this giving us an error? Doesn't true equal true?
if there is only one equal sign, then it's like we're assigning value.
Right.
And you cannot assign a Boolean as a value.
Right. So you can see here the word true here is in green, right? That's because, but the word like width or height is not in green. And the reason is that green words are sorry, are reserved words. So these reserved words, like type is also green, right? Functions, function names, and reserved words are cannot be assigned values. So here you are trying to assign the value true to the reserved word true, and it won't let you do that. So, but the comparison operator equals equals lets you test whether two values are equal to each other. So this is what you mean, right? When we say true is true equal to true, this is a Boolean comparison, and the answer is yes. And how about true? Does true equal false? Be false. Right?
This is gonna be false.
Right. And what about this one? Is it true that true is not equal to false? Right.
Yeah, it's true.
True. So you can use the exclamation point equal to test the Boolean comparison not equal. Right? Now I'm gonna run these. Now what did I just do with these two lines?
You assigned value to A and B.
Right. So let's actually test here. What is the data type of A?
Boolean?
Yeah, it's Boolean now, right? And B as well. So now if I test A equals to B, is that true or false?
False.
False.
False, right? Because A is true and B is false, and these things are not equivalent. Now what if I run this? What did I do with this line?
Assigned B to A.
Right, and what was B?
False.
B was false, and now I assigned A to equal B, so now A will also be what?
False.
False, right? So up here it was true, but when I assigned A to be B, now A is false. So if I run A equals to B, what will this give me? True or false?
True.
That sounds like a very hesitant true. Is that true?
It's
Who
gonna
thinks
be
it's
true.
gonna be
Yes.
true?
True.
Who thinks it's gonna be false? Any false takers? Okay.
Oh, name B is not defined.
So here we define B as false, and here we redefined A as being equal to B, which is false. So A and B are both false now. So so A is A equivalent to B? Yes.
True.
Yeah, because both values are false. So false is equivalent to false, and is A equivalent to true?
No.
False.
False.
This will be false because A is false and it is not equivalent to true. Is it true that A is not equivalent to true?
Yes, it's true.
Yes.
Yes, that's true. Right. So this is the Boolean logic can be a little bit tricky, and just be careful when you're using the double equals and the equals, because you might actually, if you accidentally use the equal when you meant to use the double equal, then you're actually reassigning your truth values and rather than like testing them. Okay, and then we also have the Boolean algebra operators and, or, and not. So true and true is what?
True.
Right. And true and false is what?
True and false. True, false. Okay.
So for the Boolean operator, true and false is going to be
False, false.
False.
right. And what about false and false?
It's true.
True.
Oh, it's false.
False. Right. So these are going back to our like truth tables, right? T and T is T, T and F is F, F and F is F, right? So what about true or false?
True.
True. And what about false or false?
False.
False, right. Okay, what about not true?
False.
False.
Okay, and not false,
True.
True.
right? Okay, what about this statement?
True.
So, okay. It's true. Inside we have true or false, which is true, right? And then true and true is true. So the parentheses allow us to create nested Boolean statements, right? Okay, and then the negation of that will be
False.
False.
right. Okay, so we're just kind of playing games right now with these, but actually these things are very useful when you're especially we'll see on Tuesday and Thursday when you're using selection statements, if, right, or complicated selection statements like if or else if or else. In these cases, sometimes the statements that you construct to decide whether you're going to move into this code for the selection statement can be quite complicated. And often they're some kind of combination of Boolean logic, right? So understanding how to construct these, especially with parentheses and nested statements, is very helpful. Okay, so we can also assign these. So A equals true, B equals false. Now, what about this statement?
It's true.
So let's evaluate this from the inside out. So true or false is what?
True.
True.
Okay.
True.
And then false or true is
True.
True.
right. Okay. Okay. I also want to just to give you a warning that Python doesn't understand the semantic value of your variables, right? So true with a capital T is a protected word, is a keyword, right? And false with a capital F is a keyword, but true with a lowercase t is just a variable name, right? It's just an arbitrary, it could be true D, right? It could be truly, right? Truly happy, right? It could be anything, but true is just a variable name. So I can assign the value false to a variable named true. And I can assign the value true to a variable named false. Okay, what will this statement give me?
True.
But it's not true. Shouldn't not true give me false?
Yeah, but true is assigned for false.
Right.
So the
And
meaning is not false.
not false, right? So not false is true. So in this case, not true is true. And how about this one?
False.
This one is false.
Right. Not false is false, ironically, but it's because false has been assigned a value of true. Not true is false. So this is just a warning because oftentimes when we are constructing variables as to indicate like a state of our algorithm, we can accidentally create a Boolean flag or Boolean variable which has the opposite meaning or a different meaning than we mean to give it, right? So this is just kind of a rudimentary example of that. You could also, create the variable not true equals false and not false equals true, right? And then not true. What would that give me? So not true, that's also true, because this is false, then assign the value of false and so on. So, okay. All right, so interesting fact, Booleans can also be treated as numbers. The reason for this is that in Python, Booleans are allocated 1 byte. Sorry, not 1 byte, 1 bit. So a bit can be either a 0 or 1. And so the Boolean value, the Boolean value of true equals 1 bit, and sorry, the bit value of Boolean true is 1, and the bit value of Boolean false is 0. So if you look at the integer, if you cast true as an integer, it'll actually give you 1, and if you cast false as an integer, it'll give you 0. So if you use numeric operators on Boolean values, it'll actually treat them as integers. So true plus true is going to give you what?
2.
2, because the bit value of true is 1, and the plus operator is going to convert these Booleans into integers. You can also test, so is false equal to 2? Is false equivalent to 2?
False.
False. Is false equivalent to 0?
True.
True.
True. So here, this equivalence is converting false to an integer, to its integer value of 0, and finding that 0 is equivalent to 0. And similarly, true is equivalent to 1. Okay, so what about true plus false?
1.
Right, 1. And what about this?
It will be error.
It's going to give us an error for the same reason we saw before, that you can't set true equal to true because false is a keyword and you can't assign a value to it, right? So this is just an interesting fact that Python will also treat Booleans as numbers in some cases. Okay. Great. Okay, so last topic for today, strings. So KIMEP here, we can use the single quotation here to create a string. You can also use the double quotation to create a string. And notice Python is treating these things as the same thing. Okay? So whether you use the double quotation or the single quotation, Python is treating this as a single quotation. Right? If I want to write KIMEP's best, this is going to give me an error because I'm using a single quotation, but I'm also, my single quotation here are paired, right? So that is going to end the string here, and then I am adding some characters on here which don't fit, which don't belong, so it's invalid syntax. So one way to include this apostrophe inside of the string is to use different kinds of quotes. So if I use the double quote for this statement, then I can include single quotes or apostrophes, and it will accept that. Right? But I don't think the opposite is true. So I don't think you can do. Oh, let's find out. Maybe you can. Yep, you can do that as well. So if you wanted to write like KIMEP's best, ironically, you could do single quotes to define the string, and in that case, it would treat the double quotes as characters in that string. Yeah. Okay, another way, if you're using single quotes, is to use this backslash. A backslash is an escape character, which tells Python to treat this apostrophe just as an apostrophe. Don't treat it as the beginning or end of a string. So in this case, it will also give you this string with the apostrophe. And here you can see if you use the double quotes with no internal apostrophes, it treats it with a single apostrophe. But if you write this with an internal quote, then it's going to define the string using double quotes, right? So that it's not, you don't get the single and double quotes confused. So this is actually, this can actually be pretty confusing. Like you can run into a lot of trouble sometimes, especially when you're trying to nest apostrophes or quotes inside of strings. But you just have to play around with it. So in strings, you can also do some operations on strings, such as a plus sign. So if I define, if I set A equal to the value of KIMEPs with the apostrophe and B as best, now A is KIMEPs, B is best. A plus B is actually going to concatenate these two strings, KIMEPs best. Notice there's no space between S and best because it's simply taking the characters in A and the characters in B and smashing them together. Okay. If I want to insert a space between KIMEPs and best, I can write it like this. I can write A plus this string with a white space plus B, and that will give me KIMEPs best with a space between the S and the B. Okay? You can also use, this is kind of a clever use of the multiplication operator on strings. So you can run 3 times B is going to give you that string 3 times in a row. So you can do numeric operations on strings to some extent. What's this going to give me?
KIMEPs best, best, best.
Yeah, with no spaces, right? But if I wanted to insert a space between KIMEPs and best, I could use this space and space plus B. So this will give me space plus best, and 3 times that will give me KIMEPs best, best, best with spaces. Right? So what happens if I move this here, over here? Sorry. What's this going to give me?
We'll have only one
Additional
space.
It's gonna be KIMEPs and then space and then best, best, best together, I
Right.
guess.
Right. Exactly. Okay. Okay. Now another. I should have had a subheader in here. If you're mixing strings and integers, mixing strings and numbers can be annoying sometimes. So let's say we define C as the integer 3. Now what's going to happen if I run this string?
Error.
Yeah, what I want to show up is KIMEPs space best space 3, but I'm going to get an error because, oh, sorry, because I didn't define C. Here, I got to run it. Okay. Now I get an error because you cannot concatenate a string and an integer. Right? So I'm trying to, A is a string, the space is a string, B is a string, the space is a string, but C is an integer, right? So you can look at type C, it's an integer, it's the number 3. Oops, sorry. But I can use, in the same way that I used integer up here, in the integer function to recast a Boolean as an integer, I can also use the string function, string with the parameter C, to convert the integer 3 into a string. Right? And now if we look at the type, let's save that. Let's call this E. So now if I look at the type of E, what's the type of E going to be?
String.
Right. So E here is the number 3. Let's just cut that out. Okay, what if, yeah, right. Okay, so now if I concatenate A space plus B plus space plus E, what should that give me?
KIMEP's best 3
Right,
with spaces.
with spaces, right. Great. What if I want to convert? So we know E is a string. What if I want to convert that back to a number?
Should use int.
What's this going to give me? 3
error.
plus E.
Error is gonna be
It's
error.
going to give me an error for the same reason. The same reason that I couldn't concatenate a string, an integer with a string. I can't do I can't add a string and an integer, right? So here I can cast E as an integer, right? And what's that going to give me?
3E maybe.
Yeah, so if I use the int function, this is going to recast the string 3. It knows that the string 3 can also represent the integer 3. So it's going to recast the string 3 as an integer 3, and that's going to give me 6. Right? So you can use the string function and the int function to recast strings and integers. And there's also a float one. I think you can I think this will also give you right. So this recast the number 3, not as an integer, but as a float 3.0, and then the integer 3 plus the float 3.0 will give you a float 6.0. Okay, so let's go back to this though. So KIMEP's best. So I'm just defining D as KIMEP's plus the space plus best, right? So the last thing I want to show you on strings, or a few things, the next thing I want to show you on strings are indices. So I told you that string is a primitive data type, but in reality, string is a sequential data type, just like a list, right? It's a sequence of characters, right? KIMEP, and so you can actually use these square brackets to index the characters or subset of characters in the string. So Python sequences begin with 0. So D0, what's this going to return? The 0th element, the 0 index element of D. So D is KIMEP's best. What's D0 going to give me?
K.
Okay, right. So it's a very common mistake to index like this. What's D1 going to give me?
I.
I, right? So this is fundamental. You have to remember this. Python always begins indexing with 0. So what's D5 going to give me?
Single quotation.
What's that?
I think it's the apostrophe.
That's right. Right. So K is a 0, 1, 2, 0, 1, 2, 3, 4, 5. So the 5th element, it's actually the 6th element, but the index 5 element is the apostrophe, right? Okay, you can also use negative indices to index from the right to the, pardon me, from the right to the left. So D minus 1, what's that going to give me?
S.
T.
The last one.
T.
Ooh, S or T?
T.
It's going to give me T. Right. So the sequencing beginning with 0 is true from left to right, not true with the minuses. So this is just an arbitrary way that Python does it. There's no like consistent logic with this. So what's D minus 3 going to give us?
E.
Right. Okay. You can also, this is called a slice of indices, a range slice of indices. So inside of the square brackets, if you use the colon, this will give you a slice of indices from 1 to 5. This is also confusing because includes 1, excludes 5. So in other words, 1 through 5 equals 1, 2, 3, and 4. It doesn't include 5. So what's what are indices 1 through the 1:5 going to return?
IMAP without K.
Yeah, it's going to give you
Without apostrophe.
Right, IMEP. Right. Okay, so you can also use the length function to find the length of a string or any sequential data type. So len of D is going to give me 12, right? Because this is 1, 2, 3, 4, 5, 6, 7, 8, including the empty space, 9, 10, 11, 12, right? So it's going to give you the length. What about D12? What's that going to give me?
KIMEP's best with space.
Nothing, because there is no 12.
Ooh,
Yes,
so
I
what's
guess
it going to
it will be
return?
error.
It's going to give me.
Yeah.
It's going to give me an error because it's the index is out of range, right? So there are 12 items in the list, but they're indexed from 0, beginning in 0. So the last element of the list is going to be what? What's the last index of the list?
11.
11, right? So D11 is going to give me that T, but D12 is going to give me an error. So when I'm coding, I make these mistakes every single day. I make these mistakes every single day because I forget, okay, yeah, Python sequences begin with 0. Because range slices using this don't include this last number. They only include like up to the one before it. Indexing the length is going to give you the error, right? So these are just some things you have to remember when you're indexing. Okay, if I want to get the word, so remember D equals KIMEP's best. Let's just remember this. How can I get the string best using positive indices? So what do I need to put in here to get KIMEP's best? To get the word best?
-1, -4.
Okay, so that's maybe using negative indices, but how about using positive indices?
From 8 to 11, maybe.
Okay.
8 and then nothing. Because 8 to 11 would be best. But if we leave this second option empty, it would be best.
Okay. What about 8 through 12? Okay, so here are 3 ways, right? 3 things. 8 to 11, remember when your index, 11 is your last index, but it's not included when in this slice, right? So this 8:11 is going to give you indices 8, 9, and 10, but not 11, right? So here you can actually use the 12th index, even though D12 gives you an error. Here you can actually use 12 because you're not it's not actually, you're not asking it to return the 12th index, which doesn't exist, right? So this is going to give you, this notation will give you 8, 9, 10, 11. And as somebody mentioned, 8 and just leaving this empty will also just give you to the end of the, I like this notation better because I don't have to calculate, but I don't have to worry about it. Right? This is going to give you from the 8th index all the way to the end. Okay, how about negative indices?
-1 of -4.
Okay. So let's try that. Ooh,
-4, -1.
Since it's excluding the last one, this probably should be -1, -5.
what are we going to try?
-4, -1.
-5
-4 and then
or 0. Just -4 and then empty space.
-5, -1.
So I think we're on, I think the -4 is right. The question is, if you include -1, you're going to cut off the last one, right? But if you include 0,
Just
you're not going to
minus.
get anything. So in this case, if you want to go to the very end, you just leave it empty. So there's no way to index using negatives. There's no way to index the last one because that's the problem with Python's the way they're indexing when they start positive indices with 0, but they start negative indices with 1. So right, so you just have to do it like this. It's not consistent. The negative indexing and the positive indexing are not consistent. You just have to, know how they're doing it. Okay, D20. What's this going to give me?
Nothing?
Error.
Error.
All right, it's going to give me an error because it's out of range. What about this?
KIMEP's best, maybe. Or
So it should be an
Error?
error. It should be an error,
Oh.
but it's actually going to handle it differently. So it's going to give me it's just going to give me a null. So that's, it's again, it's like not super consistent, but yeah. So when you're out of range, when your index is out of range, it'll give you an error. But when your range slice is out of range, it's just going to give you this. And that's why up here, that's why we got this, and that's why we got this, because these were just it just didn't understand them. So, okay. Yeah. What if you do like backwards? What if you do like? What about that? What's that going to give me? It's also going to give you the, I mean, it is an error. It is an error in indexing because it doesn't recognize this kind of backward, notation. It's not going to give you the indices in backward, but it's going to treat the error as an empty string, not as an error. So. Okay. Okay, I'm going to mute you all and you can come back in. Okay. All right, so a few more fun operators in using strings. So recall that D is KIMEP's best. The in operator is very useful. Like I love using the in operator for when I'm dealing with text. It's actually a logical operator to tell you whether a substring is contained in a larger string. So Okay, is KIMEP in KIMEP's best? That's true, right? And this is true. What about this? KIMEP's in D, is that true or false?
False.
False.
False, right? But if I add the apostrophe, then it'll be true, right? Okay. What about this statement? Is A greater than B?
If it counts the amount of characters in it, then probably it's true.
Okay, so let's try that. Oops, sorry. Okay, so A greater than B is false. But length of A versus length. So what's the length of A? 1. What about this? Greater than or equal to. Yeah, so the length of A is 1, the length of B is 1, so 1 is greater than or equal to 1, that's true. The reason why A is greater than B is because Python knows when we use this operator on characters that we are actually asking about alphabetical order. So this operator is actually giving us responding to alphabetical order, right? So is B greater than A in alphabetical order? Yes. Right. So in terms of alphabetical order, A is smaller and B is larger, right? So anything like C, if anything which comes after A in alphabetical order, this greater than operator is going to treat as larger than A, right? So is Nazarbayev greater than KIMEP? Well, we know the answer semantically is no. We know KIMEP is the best, but alphabetically is Nazarbayev before or after KIMEP? So is this going to be true or false?
True.
Yeah, this is going to be true because N is before, it comes after K in the alphabet. And so Nazarbayev is going to be treated as larger than KIMEP. What about Kaznu? Is Kaznu going to be Kaznu greater than KIMEP? Is that true or false?
False.
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 Maybe it should be greater and
False, yeah.
equal.
It's going to be false because
in
here,
this case,
because KA comes earlier in the alphabet than KI, right? So what about this? Is that going to be true or false?
False.
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 It's going to be false because here Python is treating 1 as a letter, right? KAZ and the letter 1, but the letter 1 also comes before the letter 2. So this is going to be false. What about this? Is that going to be true or false?
false.
So it's true. The reason is the way that Python is determining this is the ASCII binary character table. So here, the letter A is given an ASCII code, and the capital letter A is given an ASCII code. And then, actually, let's see. So you can look these up. This is ASCII character to binary chart. So here's in the ASCII table, like the numbers like 0, 1, 2, 3, etc., are oh, yeah, here we go. So the numbers come before the letters, right? So 0, 1, 2, 3, these ASCII codes are smaller than the A, B, C, D, E, right? So, and then the capital letters A, B, C, D, E are larger than the lowercase letters A, B, C, D, E, right? So if we look here, so A is larger than 1. Actually, that's not true. Against what it said. Oh, actually, I don't know the logic, but oh yeah. So what about this? Is capital A greater than lowercase a?
True. Maybe. Oh,
So yeah. So I don't know what I'm talking about. Here, I think the oh yeah. So the numbers are coming first, and then the capital letters, and then the lowercase numbers, right? So the numbers are going to be smaller than all the letters, and then the lowercase numbers are going to be smaller than all the uppercase letters, because it's according to this the ASCII conversion of numbers, and then capital letters, and then lowercase numbers. So what about this? Is lowercase a greater than uppercase Z? Is that true?
Yes, it is true.
Yes, true.
So alphabetically, Z is larger than A, but in the ASCII table, all of the capitals come before the lowercases. So all of the lowercases are going to be larger than the uppercases, right? Yeah. Okay, so this is just interesting. These comparisons and the way that Python treats ASCII characters can be exploited when you are coding things like variables. And also, I use this feature when I'm coding dates and times. So I like to code, like, for example, year, month, date, like this. For example, 2023, 0808, and then date 2, 2003, 0809. And the reason I like to code them this way is because I can, even if I code these as a string, I can exploit this comparison of ASCII characters to give me accurate comparisons of which dates come before or after other dates, right? So August 9th comes after August 1st, sorry, August 8th, right? So if I try this here, oops, sorry, I remember this. Right, date 2, sorry, date 2 is going to be larger than date 1. August 9th is later than August 8th. But the reason why this comparison works is because I'm coding these date strings in a way that exploits this kind of ASCII comparison, right? So you can even include like hour and minute, hour, minute, second, right? So 2023, 0808, 1300 hours and 15 minutes and 49 seconds, right? So you could, right, you could even make these down to the second, and you would still get accurate comparisons, right? Even you're not saving these numerically, right? Because if you, but you are kind of encoding like year, month, date, hour, minute, second in a way that the comparison when it's converted to ASCII is still going to give you intuitively accurate comparisons, right, of time and date. So this is just a feature that you can use when you're coding dates and time. Okay, so that's all I have today. Tomorrow we're going to talk about lists and dictionaries. So today we talked about integers, float, Boolean, and strings. We talked about converting strings to integers, integers to strings. We've talked about all the different types of operations you can do on integers, on Boolean types, and on string types. Tomorrow we'll jump into these more kind of complicated data types, such as lists and dictionaries. So any questions about what we've covered today?
Hello.
Did you guys feel that this was like the level was appropriate for what you were expecting? Is this what do you feel like the pace was fast enough, too fast, too slow?
It was okay.
Yeah.
Yeah, in the beginning, it was, I mean, I felt like it goes too fast, but then I caught up with the
Okay.
contents. Now it feels okay.
Okay. All right. So I'm gonna aim to hit the same pace tomorrow when we're talking about lists and dictionaries. Things get a little bit more complicated, but I don't think it's too much. It won't be too much different from today. And if you have any questions or whatnot, that you think the group will benefit from, go ahead and ask those questions in the Telegram. If you have questions about your specific situation, like trying to get your software set up or you can't access Moodle or whatever, please send me those one-on-one in the Telegram. So that's all for today. And I'll see you guys tomorrow at 9 a.m.
Thank you so much.
Okay,
Thank
thank you so
you.
much.
Thank you. Good day.
Have a good day.
Thank you. Goodbye.
Bye.
Goodbye.